In this problem, I gave you a function and the value of a. I want you to find the Maclaurin series, find the Taylor polynomial, and then determine the radius of convergence of the Maclaurin series. So first of all, we have to determine find the derivative, and then the derivative at a equals to 0, and then the term. So how many terms should we use? Let's use 5 terms. So n equals to 0, 1, 2, 3, and 4. So for the derivative, when n is equals to 0, we have f of x equals to 2 to the x. When n is equals to 1, the first prime. So what is the derivative of 2 to the x? So remember this, the derivative of b raised to the x power, where b is a constant, so the derivative is equals to the function itself times ln(b). So back to our problem. So this is 2 to the x and then times ln2. And then the next derivative, which is the second derivative, double prime of x. So we have 2x that produce, so the ln2 is a constant. We don't need to worry about that. We only need to take the derivative of 2x. So that gives you a 2x ln2, and then we still have another ln2. So this ln2 is straight from here. So every time you take a derivative, you produce an extra ln2. So that is 2x times ln2 to the second power, and then triple prime. So that is the derivative of this is 2x ln2, and then you still have 2 more ln2. So you have multiply ln2 and ln2. So you have 2 to the x times ln2 raised to the third power, and then the fourth derivative. So this one, the 2 to the x produce a 2x ln2, and then you still have a ln2 to the third power. So this one multiply ln2 to the third power. So you have 2 to the x times ln2 to the fourth power. All right, so that is all for the derivative. And then the next thing that you will have to do is you have to plug in a equals to 0 for the Maclaurin series. So let's do that. So when x is equals to 0, f of 0, so this is 2 to the 0, that is equals to 1, and then a first prime 0, so that is 2 to the 0, ln2, which is 1 times ln2, that is equals to ln2, and then second prime 0, so that is 2 to the 0, and then ln2 raised to the second, so you have a ln2 raised to the second, and then the triple prime, so you have 2 to the 0, ln2 to the third, so you have ln2 to the third, and then the fourth prime 4, and then 0, so this is 2 to the 0, and then ln2 to the fourth power, so you have ln2 raised to the fourth power. All right, and then you have to write the expansion and then determine the Maclaurin series. So in this function, we have f of x that is equals to 2 to the x. The first term is equals to 1, right? Oh, actually, we have to do one more because we haven't done the terms yet. Okay, so let's do the term. Let's erase this and then we do the term. So the first term is, let's use another color for the term. So we have, according to the Maclaurin series, we have to take the result of the plug-in, which is 1, divided by a 0 power, and then we have x minus 0 raised to the 0 power. And then we have the result of the next plug-in, which is ln2, divided by 2 factorial, and then x minus 0 to the first power. Then that will be a 1 right there then. Then this will be a 1 factorial. And then we have ln2 square divided by 2 factorial, x minus 0 square, and then we have ln2 to the third divided by 3 factorial, and then x minus 0 to the third power, and then ln2 to the fourth divided by 4 factorial, x minus 0 to the fourth power. Okay, so this will be equal to, you know what, I will just write the the function f of x that is equals to 2 to the x, which is equals to the first term is 1 divided by 0 factorial x minus 0, and then plus ln2 raised to the first divided by 1 factorial x minus 0 to the first, and then plus ln3. I don't think we need the 0. We need to write the plus 0. So ln2 to the third, to the second, and then 2 squared, and then we have x squared, and then plus ln2 to the third, 3 factorial, and then this is x raised to the third, and then plus ln2 to the fourth divided by 4 factorial, and then x raised to the fourth power. And then we keep on going, right? So overall, what is this? This is the Taylor polynomial, and then the Maclaurin series is summation n goes from 0 to infinity. Let's find out the pattern. So the top we have an ln2, right? So that will be ln2, and then the power I will use not 0. I will use an n. So when n is equals to 0, that's how we got the 1. When n is equals to 1, we have a 1. When n is equals to 2, we have a second power, and then the denominator I will use n factorial, and then the rest that will be x raised to the nth power, and then this is my Maclaurin series. And then the top is the Taylor polynomial. All right, what else do we have to do? We have to determine the radius of convergence, right? So to determine the radius of convergence, I will apply the ratio test. So the ratio test first, I have to determine the series, which is ln2 to the n divided by n factorial, and then x raised to the n, and then the next term is n plus 1. So that is ln2 raised to the n divided by n plus 1. This is a n plus 1 factorial, and then this is a x to the n plus 1, right? And then we simplify that. That is equals to ln2 raised to the n, and then ln2 to the first, x to the n, x to the first, and then n plus 1 factorial. No, we don't do factorial in there. N times 1, n plus 1, and then times n factorial, because we want to do a cancellation. And then we do a limit as n approaches to infinity. We have an plus 1 divided by an. So that is equals to limit as n approaches to infinity. What do we have? We have ln2 to the n, and then ln2, and then x to the n, x to the first divided by n plus 1, and then n factorial, the reciprocal of an. We have n factorial on top, and then the rest goes to the bottom. ln2 to the n, x raised to the n. All right, let's do a cancellation. So first of all, ln2 raised to the n, and then n factorial, and then x to the n. So they are all gone. And then what do we have right here? So let's see. The limit as n approaches to infinity. Okay, the x, we have one x term, and then other than that, we have an ln2 divided by, so we have a ln2 raised to the first divided by n plus 1. What else do we have? And then we have to multiply the absolute value of x. So since ln2 is always positive, and then n plus 1 is always positive, because n goes from 0 to infinity, right? So when n is equals to 0, we have a positive, then we don't need to put the absolute value on the n ln2 divided by n plus 1. Okay, what happened when n approaches to infinity? You have ln2, which is a real number, divided by infinity, so that is equals to 0, times the absolute value of x, so that is 0 times the absolute value of x, and this is always less than 1 for any x. All right, and then so we say that the series is convergent for any x value. And then you can draw a picture. So the radius of convergence, we don't even have a compound inequality, so that means it's always convergence anywhere. So the radius of convergence, there are two ways to write it. You can say x can be any number you want, so x is an element of all real number, or using interval notation, you have from negative infinity to positive infinity. So for the Maclaurin series, what kind of x value do we need in order to make the series convergent? The answer is you can let x be any value you want. All right, so that is the end of this problem. If you think my instruction is helpful, let me know in the comment section below. Like the video, share the video for me. Appreciate your help. Subscribe to my channel if this is your first time visiting my channel. I'm sure I have a lot of video that helps you to learn series. All right, I will see you all in the next lesson. Signing off for now.